Hello, today we're going to talk about Reactivity 1.3.3, and this one is all about fossil fuels. Alrighty, so fossil fuels are non-renewable energy sources that take millions of years to form. And they've generally formed from the reduction of organic matter. But again, it takes a really long time. So I want to remind you of the organic definitions of reduction. Could be gaining hydrogen or losing oxygen. So that's why you'll typically see fossil fuels are going to be hydrocarbons, because they're going to have more hydrogens or less oxygens than some of the other organic fuels that you might find, like alcohols. And we're going to talk about three in particular today, three fossil fuels in particular: coal, crude oil or petroleum, and natural gas. Okay, so coal is like the solid rock form of fossil fuels that has resulted from like millions of years of plant matter or animal matter decaying and being reduced, so that way it has a lot less oxygen and is mostly carbon and hydrogen. So that means coal winds up being between something like 80 to 90% oxygen, 80 to 90% carbon by mass, because it's lost oxygen and it's gained hydrogen through that reduction process. So lots and lots of carbon there. And then using coal as a fuel source is one of the reasons that the Industrial Revolution happened. And we're going to get into more of the advantages and disadvantages of using coal on a later slide. Now, our second type is crude oil, which is a liquid form of fossil fuel that it is used for a wide variety of things, including fuels. Sometimes we'll call this petroleum, but you can typically, once oil is extracted from the earth, you can separate it into different fractions for different purposes. But it tends to be really longer chained hydrocarbons. They could be saturated, they could be cyclical, they could be aromatic compounds, but they are liquid. Then they are used as a fuel source, so things like gasoline or petrol. But they can also be used in the production of different organic industrial products, so like in plastics particularly, like polymers, pharmaceuticals, dyes, but those are petroleum products. So one of the considerations for using crude oil as a source of fuel that we're just going to burn is that we don't have as much to make those industrial products. So again, there's going to be advantages and disadvantages we'll talk about with using crude oil, but this is our second source of fossil fuels. Okay, and our third source of fossil fuel is natural gas. It's the gaseous fossil fuel that we're talking about, and it's typically mostly methane. We'll talk about with natural gas. But you'll see it's often contaminated with like nitrogen and sulfur oxides. But it tends to be one of the cleaner sources of fossil fuels compared to coal or crude oil, because methane has a lower percentage by mass of carbon. Since it's CH4, you're going to have a slightly lower percentage there, and so it's going to produce a little bit less carbon dioxide when it's burned by mass. However, it is harder to transport because it's a gas, so you need to take that into consideration as well. So let's summarize some of those advantages and disadvantages of these fossil fuels. We'll start with advantages. So some advantages is that, like, especially with coal is very cheap and it's plentiful and has a long shelf life. It tends to be safer than some of the other fuel sources like nuclear power. Crude oil, petroleum products, those are easy to transport because of their liquid form. They can go through pipelines. You can put them in tankers and carry them around. They tend to have a high energy density, And then for natural gas, burns the cleanest of the three. And natural gas, if you get it like pure methane, it's not going to contribute to acid rain. Let's talk about disadvantages. So all three of them, because of their carbon sources, will produce CO2 as a byproduct. And the CO2 contributes to global warming or global climate change. All three of them have limited supplies, like finite resources, because they take millions of years to produce. So eventually we're going to run out of them. Pretty much all of them have the possibility of producing carbon monoxide as a unwanted product and through incomplete combustion. And for coal and crude oil, they could contribute to acid rain because they tend to have sulfur or nitrogen impurities, and those sulfur oxides, nitrogen oxides can react with water vapor to produce acidic products, which can lower the pH of rain. One way that we can measure the efficiency of fuels is something called specific energy, and it's the energy released. Energy released, it's usually in kilojoules per unit mass. So it's usually kilojoules per gram. So you can take the combustion, and if you have something like heat of combustion, which is in kilojoules per mole, you can change that to kilojoules per gram. And this helps us to be able to compare things when you need to be able to transport them, or just like how much of the stuff it takes to burn to release the same amount of energy. So we use specific energy to kind of compare the efficiencies of these different fuels. So carbon dioxide levels have been increasing in the atmosphere since the burning of fossil fuels became commonplace. And this is an important thing to consider because carbon dioxide is a greenhouse gas. So remember that carbon dioxide looks like this, okay? And when energy from the sun is approaching the Earth, right, it can get to the Earth through the atmosphere. This is my Earth, okay? Let me spell this properly. Earth. When that energy bounces off the Earth and goes back to the atmosphere, carbon dioxide, among other gases, can absorb infrared radiation. So instead of allowing the infrared radiation to pass back up and out and away, that doesn't happen. It gets absorbed by the carbon dioxide because it is infrared active. Okay, it's IR active. And so because it's absorbing that, it is trapping the energy, which it provides this greenhouse effect that we're talking about. So it's taking in the energy from the outside, but trapping it. And so that's kind of what why we get the word greenhouse effect, because that's what's going on. If you have a greenhouse to grow plants, you're pulling in energy from the sun, but trapping it inside the greenhouse. So this effect is becoming greater over time as we get more and more carbon dioxide levels in the atmosphere. And this contributes in a lot of different ways to global climate change because it's trapping that infrared radiation and not allowing the heat to dissipate. Okay, so this sample of coal has some carbon, hydrogen, oxygen, nitrogen, sulfur, and we want to determine the empirical formula. So this is a good chance to review empirical formula. You pretend the percents are grams. So if you assume that you have a 100-gram sample, and you can convert the grams to moles using the molar mass. And this one, we've got 5 different elements. So we have 7.08 moles of carbon, 5.08 moles of hydrogen, 0.472 moles of oxygen, 0.0521 moles of nitrogen, and 0.0525 moles of sulfur. Now the smallest one is 0.0521, so I'm going to divide all of them by that smallest one to get my mole ratio. Now, remember that this isn't just a single compound. We're determining the empirical formula for this, but it's really more of like a ratio, since they're all kind of in this solid mass. So you're going to see some weird numbers. For carbon, I got 136, hydrogen 98, oxygen 9, nitrogen 1, and sulfur 1. So you could write that as a molecular formula, but I'm not sure that that's the most accurate thing to do. So I'll write it like this, but an S. But really, if you wanted to say carbon to hydrogen to oxygen to nitrogen to sulfur, 136 to 98 to 9 to 1 to 1 as ratios, I think that's a little bit more accurate. So you can see how much, by moles, how much more is carbon and hydrogen compared to the other elements. But by mass as well, you can see the really large percentage by mass of carbon in there that is contributing to the like energy density of the coal. So then it says, explain how the combustion of coal could produce acid rain. Give equations to illustrate how the elements in the coal can produce acidic gases. So the carbon itself could make carbonic acid, but that does not contribute very much. What's going to be more of an effect is the nitrogen and sulfur. The nitrogen could react with oxygen, combustion reaction, to form nitrogen oxide. And then that nitrogen oxide could be further combusted to form NO2 gas. Now, this NO2 product is the important one for acid rain because it can react with water vapor to produce nitrous acid, excuse me. It could also produce nitric acid, both of which are contributing to the low pH of acid rain. Now, sulfur is also going to do a very similar thing. You have sulfur reacting, producing sulfur dioxide. Sulfur dioxide can react with water vapor to produce sulfurous acid, which again contributes to the low pH for acid rain. So this links to structure 3.2. Why do larger hydrocarbons have a greater tendency to undergo incomplete combustion? Well, they have a larger percent by mass of carbon. If they have a larger percentage carbon, then it's going to require more oxygen to completely combust it into CO2. And as long as you have plenty of oxygen, it could eventually do that, but it takes less oxygen to do incomplete combustion and produce carbon monoxide. So the greater the percentage of mass of carbon you have, the more likely it will be for incomplete combustion. Now this links to the higher level concept in structure 3.2. Why is carbon dioxide described as a greenhouse gas? And it's because it can absorb infrared radiation, blocking it from leaving the atmosphere. So it like keeps the energy on Earth. So it warms up the atmosphere effectively, just like a greenhouse would, where you're letting the energy in, but you're trapping it inside and not letting it out. Now, we talked a little bit about some of the disadvantages of using fossil fuels. So things like pollution, producing carbon dioxide, which is a greenhouse gas contributing to global warming, global climate change. It also, when you're burning some of these fossil fuels for fuel, then you can't use them for making other consumer products. But I want to leave this kind of as an open-ended. I'm sure that there are other impacts that you can think of, especially since this is a nature of science connection. You guys should try to connect this to some of your other coursework, particularly if you're taking things like environmental systems and societies. or some of your like other group 3 topics, it's worth like spending some time to think about this outside of just the chemistry implication.